So in this video, let's talk about escape energy, bound states, unbound states, and etc., and how to read a K plus U graphs and to determine if they're correct. So let me ask you a question. I have three K plus U graphs here, and I want to figure out which one goes with which. Okay. So what if I'm in a scenario where you're at Mars, right? And you got some rockets and you blast off from the planet, okay? And you reach a certain distance away, and you're like, okay, well, I want to leave Mars for good, but at some point I want to stop. Okay, so I want to leave for good, but at some point I want to stop. Okay, but which one of these graphs will represent that idea? Well, so it turns out that this graph will represent this idea. Okay, and the idea is you want to leave for good, but you actually want to be completely stopped. Well, let's read this graph. Our K plus U, or kinetic energy plus potential energy line says that, okay, well, at some point I'm going to go very far away. Okay, at some point I'm going to go very far away with my with my kinetic energy being slightly decreased, but my potential energy also decreasing. Okay, so this idea represents the fact that we're in an unbound state. Okay, it's not bounded, it's going to escape. Okay, so this is what we call escape energy. And so this, if you want to be in a scenario where you escape away from that planet forever, but you want to be completely stopped at the same time, this is a graph that makes logical sense, and we're going to make sense of this in a little bit. Okay, so let's switch the scenario. What if I wanted to what if I'm at Mars and I blast off and I never want to come back? I don't ever want to come back. Neither do I want to be completely stopped. Which one of these graphs will represent that idea? Also, it turns out it will be this. Okay, and the reason being, well, why? Well, look, as my potential energy decreases and as my distance increases, yeah, as I potential energy decreases to go to zero, I still have my kinetic energy. Okay, I still have my kinetic energy, which is just keep on going, which means my object is keep on moving and it's constantly moving. Okay, so my kinetic energy is actually not going to zero at all. And so you could see that when my potential energy is at zero, my kinetic energy is at maximum, my object is still moving and just moving forever. So this one will represent that idea. While in the same case, well, if I want to move away for good, but I want to be completely stopped at the same time, you can see that my kinetic energy will eventually go to zero. And so that means that my motion will stop. There's no zero, there's no kinetic energy, there's no potential energy. My object is at zero. Okay, well, not no potential energy. When my kinetic energy decreases, my potential energy is actually increasing. So when I have maximum potential energy and no kinetic energy, that means my object is at rest. Okay, so that's the idea. Now, let me explain something here. Whenever, so let's put it here. Whenever K plus U, okay, so we say a state is bounded when K plus U is less than zero. Okay, so when K plus U, when your kinetic energy plus your potential energy is strictly less than zero, we say this is a bounded state. Okay, which means that you cannot escape. Okay, now when K plus U is greater than or equal to zero, we say we're in an unbounded state, and so thus we will escape. So these are for unbounded states. So notice when K plus U is greater than or equal to zero, we're unbounded, which means that we're going to escape. Okay. Now, let's go on a quick idea of how to read these graphs, okay? We always read the sum of the kinetic energy and potential energy as from U to K, and that will give us our K plus U line. So in this case, this makes sense. I start from U and I go to K, and there's my K plus U line. But this one, I start from U and go to K, there goes my K plus U line. I start from U and I go to K, my K plus U line should be here, not down here. And so this actually doesn't even make any sense. Let's put wrong, bang. Yeah, this doesn't even make any sense. So again, that's how you read the sum of your kinetic and potential energy. You read it from U and you go to K, and that will be your K plus U line. And again, you can see that these are unbounded states. Yeah, you can see that these are unbounded states because your K plus U line in this case is equal to zero, and we said that's unbounded. In this case, our K plus U is actually greater than zero, which means that's unbounded. So this, we will actually never come back to Mars will forever keep going away, and this one will go away for a good time and then completely stop. As you could see that, or as our distance increases, or potential energy increases, or kinetic energy decreases. And guys, I want to make I'm gonna make a simplified assumption here. Well, not assumption, but something that you should look out for with these graphs. Your kinetic energy could never be negative. Okay, just keep that in mind. Your kinetic energy could never be negative. So if there's some K plus U graph and you see and your kinetic energy is actually negative below zero, then that's also wrong. Just as in this case, where a K plus U line does not fit the actual graph itself.